Hello guys, I'm a teacher Olimboka Sajigo Masame. Welcome to Olimboka Physics. We have a question below states that show by array diagrams how right-angled glass prism may be used. Roman 1 to turn array through 90 degrees, Roman 2 to turn array through 180 degrees, Roman 3 to invert a beam of light. For Roman 1, we have our right-angled prism here, incident rays, and this is reflected rays in green. We extend this incident ray with dotted line forward so that we can measure how, in what extent, this reflected rays deviate from this incident rays. You can see roughly here it is 90 degrees and it is in clockwise directions. Therefore, the net deviation is 90 degrees, negative or positive 90 degrees clockwise directions. In its application, it is in a periscope, prism periscope. We have object which is upright, and also the final object here is upright as observed by observer. This is a upright prism, and this is inverted prism, and this is point of incidence, and also this is point of incidence. Okay, and the second final ray turned 100 degrees with respect to incidence ray clockwise directions. As you can see here, we have our incidence rays. The light ray incidence is the base of the prism, and it incidents, and it is, we have 2 points of incidence, first point, second point, and after this extended forwards dotted line, we have deviation 1, and this extended dotted line in green, we have deviation 2, and therefore net deviations is in clockwise direction negative 90 degrees, clockwise direction negative 90 degrees, and it is 180 degrees clockwise directions, or negative 180 degrees. Okay, the third case, a final ray must be turned into 360 degrees or 0 degrees with respect to incidence rays, so that the invert of beam of light will occur. We have this two prism lying along horizontal directions or horizontal x-axis, and facing each other with the base, where with little sides looking through so that the rays can pass through. This is object and rays diagrams. Let us take directions of this yellow ray. We have first deviations at the first incidence. At the second incidence also we have second deviations, and this is deviation 1 in clockwise directions. This is clockwise directions. Also we have third incidence here, and we have third deviations, and a fourth incidence here, and a fourth deviations. And this observer will observe the ray of the final image as inverted. Remember, this is how the invert of the beam of light, as the incidence at A is yellow, now the upper side it is green and the lower side it is yellow, and therefore A is inverted. And this is a set of prism is used in a prism binoculars. The prism binoculars, the pair of binoculars have this set, each pair, as the lens final image formed due to refractions is inverted. Therefore, the final image, so that the observer will not see the inverted image such as animals or trees or mountains, the set of this prisms is in each pair of binoculars, so that the final image will be upright, as you can see this arrangement. Okay, you can see this arrangement, and the net deviations as usual is this of anti-clockwise directions, and this of clockwise directions is cancel each other, so that we have 0 degrees or 360 degrees. This is just a proof. Or we can also use a right angle glass prism, that is a rectangular prism. The base is at the bottom and the apex is at the top, and this is our object which is upright, and our final image of this object will be inverted, as from this case. Okay, and let us take a look of this yellow ray, so that we can understand how the net deviation becomes 360 degrees or 0 degrees. And we have now first incidence, and our deviations is through refractions, and it's deviation 1, and it is in clockwise direction, and it is almost 45 degrees. And this is second incidence, and our deviations is through reflections, and it is almost 90 degrees, and deviation 2. And our last deviations is emergence rays through refractions, and it is almost 45 degrees, and this is deviation 3. And when we find the net deviations, we'll see that it is 0 degrees or 360 degrees. It is also turns the incidence ray. Remember, the upper one is in purple, and now here the emergence is in yellow as the upper one. Okay, and the bottom one is purple. That's why we say this case and this case is same. For this second case, we can see how the image formed, the final image formed through second case as inverted image as observer sees this second case. Okay, thanks for watching. Please like, share, comment. Don't forget to subscribe to this YouTube channel for more video like this one. Thank you.